Okay, good morning, data scientists. This is Mrs. Harrison. We are going to fill in this flipbook with the intention of reviewing for your assessment, which will be later this class. So first half of class is going to be review and some practice and some clarification on things. Yes, you can use this flipbook for the assessment. That is part of the purpose of it. So let's get right into it. The faster we can get through it, the more time you'll have for the assessment. So let's do it. Let's be efficient. Here we go. The very first flap is called variables. And it's just a quick review of the difference between quantitative and categorical variables. So quantitative variables take on numerical values. They can represent either a measurement or a count. So either it's something I'm measuring, like with a ruler or a scale or a thermometer, or it's something I'm counting, the number of students, the number of apples, the number of red cars in the parking lot. So here's some examples. Height, GPA, number of students. These two would be like a measurement. This is a count. It's still quantitative variable. Takes on a number. And then we have categorical variables. So this is the other type of variable that takes on names or labels. There are literally infinite examples here, but a few examples on the top of my head. Eye color would be a categorical variable. It takes on names or labels. Brown, blue, green, hazel. Those are names or labels. Favorite class. College major. Okay, those are just a few off the top of my head, but hopefully that you can think there are literally like infinite categorical variables that we can collect data about. One key difference between these two kinds of variables is that with the mean or the median, that really only applies to quantitative variables. We can really only find the mean or the median when we're dealing with a quantitative variable. Versus if we're discussing proportions, percentages, we're comparing the sizes of groups. Typically, we're going to be talking about a categorical variable. Okay, like I said, efficient. We are done with the first flap. So you can turn to the next one. And we're going to start on talking about univariate categorical data. So univariate means one. Uni means one. So we're dealing with one categorical variable. For univariate categorical data, we're really restricted to two main types of graphs that we tend to use. Bar graphs and pie charts. That's basically the best we can do. And if we want to describe these graphs, the types of things you might think about is things like different frequencies. Frequency means how many, the count. We could talk about the proportion, so the relative size of groups. Okay, so here we have a little example problem for you to try. So here we have some data about the favorite elective class of students, and you have two tasks. Your first is to complete the bar graph by filling in the missing section. So fill in the missing part of this bar graph. The second is to label each section of the pie chart with the corresponding elective. So you're going to label this pie chart. For this, it can be really helpful to have a calculator. So if you have a calculator, get one out. If you don't, guest teacher, this might be a good time to sort of distribute the calculators on my desk out to tables. But go ahead and pause this video for about 3 or 4 minutes and let students try these 2 problems. Okay, we're back. So in terms of your bar graph, it should look something like this. There were 7 students that said PE, so we should raise our bar up to the 7. In terms of our pie chart, the biggest section here should be labeled as music. The second biggest section should be, let's see, PE. So this would be PE here. This one is going to be art. And then our foreign language and our tech were the same height. So these 2 slices are the exact same size. So these are interchangeable. So you could either label this one as language or tech and this one as language or tech. So either way, if these were swapped, it's still correct. Okay, there you have it. Univariate categorical data. Let's move on. We're going to move on to the next flap of your flipbook. And for this flap, we're dealing with univariate, so still one variable, but now we're dealing with quantitative data. This is like the meat and potatoes of the stuff we covered in like the first several weeks of this class is what our big focus was. And we learned about 2 graphs. We learned about dot plots, and we learned a lot about histograms. With dot plots and histograms, there are 3 things that we're interested in: the center, the shape, and the spread. For the center, we kind of have 2 options to choose between. We can either describe the mean or the median. The mean is just the average. And it's the measure of center that you want to use when you're dealing with symmetrical distributions. Versus the median, which is the middle value. So when I line all the values up from least to greatest, it's the middle value, which we want to use for skewed distributions. So that's kind of our rule. How do I decide between the mean or the median? Well, check the shape. Is it symmetric? Is it skewed? Speaking of shape, we learned a bunch of different words for how to describe the shape of a distribution: symmetrical, skewed left, skewed right, uniform, bimodal. And if you don't remember what these shapes look like, we have a whole note where we talked about this. So this would be a good opportunity for you to use some past resources. Okay, last thing is the spread. If you're asked to describe the spread, what you're going to calculate is the range. And the range is just the maximum minus the minimum. The biggest number in the data set minus the smallest number in the data set. Okay, I want you to try these 2 problems. So here for this histogram, you're going to describe the center, shape, and spread. And here for this dot plot, you're going to describe the center, shape, and spread. You really might need a calculator for this one, folks. You really, really might need one. Okay, so there's my hint. Okay, pause this video again for about 5 to 6 minutes and let students try these problems. Okay, we're back and we're going to talk about these problems. Okay, for this histogram of exam scores, hopefully what you said is that this is left skewed or skewed left. Okay, we can see it has this swooping left side tail, so it's left skewed. So if we have something that's skewed, what we need to determine is the median. How do you calculate the median from a histogram? Well, we've done this several times, but here's how we're going to do it. First step, determine the frequency in each bin. So, for example, we have one data point in this bin, one here, 2, 4, 8, 7, 4, 1. That's our first step. Second step, I need to know the total number of data points in the whole data set. So we're just going to add 1 plus 4 is 5, plus 7 is 12, 20, 24, 26, 28. Divide by 2, and we get 14. In other words, because this is an even number of data points, by the way, this middle, the median, would be located right here between the 14th and the 15th data point. Actually, what we need to do is average the two middles. Anyway, what we need to do is find the 14th and 15th data point, and that's going to tell us the median. It's going to determine the median. So, the way I like to do this is I'll start from the left and I'll count over until we find where that 14th and 15th data point reside. So, starting from here to here, we've accumulated one data point so far. Not good enough. Let's go a bit further. From here to here, we've accumulated 2. From here to here, so far we've accumulated 4 data points. From here to here, now we've accumulated 8. We still have not found the median yet. We're looking for 14 and 15. From here to here, now we've accumulated 16. In other words, I've passed by the median. Actually, it happened somewhere inside this bin. So this here is my bin that contains the median. The median must be somewhere in that bin. And that's the best I can say with a histogram. So what I can say is that the median is between 60 and 70. And that's the best estimate that I can give. As for the spread, what we want to do is calculate the range. And we're going to use 100 as our best estimate for the maximum and 20 as our best estimate for the minimum. And we're going to calculate 100 minus 20 to get 80. And there you have it, folks. That's our center, shape, and spread for this histogram. Let's do it again for this dot plot. Okay, for the shape, I would say that this is uniform. We haven't seen uniform as much, but remember what uniforms kind of look like is all the bars being roughly the same height. Roughly. It doesn't have to be perfect. So that it kind of almost looks like a square overall. And I would argue this one does. So, it's uniform. Also, to determine what measure of center do we use? Well, we need to decide whether it's symmetrical or skewed. And in this case, I would say it's roughly symmetrical, which means we need to calculate a mean instead of a median. Okay, how do I calculate the mean? Well, what I need to do is I need to take all of these individual data points, add them all together, and then divide by the total number of numbers. So I would need to do like 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus da-da-da-da-da. So I'm going to show you how I'm going to do this in my calculator. One thing I know is that there are 1, 2, 3, 4, 5, 9, 15, 24, 30 data points. Okay, that's how many total dots there are. So I'm going to go to a calculator app. Okay, there are 5 ones in the data set. So I'm going to add 1 plus 1 5 times. Okay, so that 1 plus 1 plus 1 plus 1 plus 1, that is representing my 5 dots on 1 here. Okay, I'm a very lazy mathematician and I don't want to enter in 30 numbers. So what I notice is that 2 plus 2 plus 2 plus 2 is just 8. So then I can add my 8. I'm going to delete this 6. That should be an 8. Plus, well, in the next one I have 6 threes. 1, 2, 3, 4, 5, 6. Which is just 18. Again, I'm a lazy mathematician. Okay. Here's my 6 threes. Here I have 5 fours, which is 20. Here I have 4 fives, which is 20. Here I have 6 sixes, which is 36. So let's add those to what I'm adding here in my calculator. So we had 20 plus 20 plus 36. Press enter. Okay, so this 107 number is my total. It's what I get when I add all the numbers up. Okay, but I'm not done yet. To calculate the mean, I have to add all the numbers up and then divide by the total number of numbers, which we decided earlier was 30. So I got to take my 107 and divide it by 30, and I get 3.566666 repeating. So I'm going to round that to 3.6. So I have a mean of 3.6. Again, all I'm doing, folks, is calculating the average. So if you know how to calculate an average, you should be good. Add all the numbers up, divide by the number of numbers. And then the last thing I'm going to do is calculate the range, which is 6 is my maximum, minus 1 is my minimum, and so I have a range of 5. Alrighty, that's univariate quantitative data, folks. Let's move on to the next flap. Here, on my next flap, I am looking at this stuff that we learned last class, all about scatter plots. So now we're looking at bivariate, bi means 2, bivariate quantitative data. For bivariate quantitative data, there's actually only one graph that we get to use, which is a scatter plot. We're going to learn to love these things, folks. In last class, we learned about the direction of a scatter plot. So whether it's positive, negative, or none. And we learned about the strength of scatter plots, whether it's weak, moderate, or strong. And the final thing we started to learn about last class was about the correlation coefficient, R. That's what that formative activity was all about. The correlation coefficient R is a number between -1 and +1 that measures both the strength and direction of the scatter plot. Okay? So correlation, it goes between -1 up to +1, where R values close to -1 are very strong negative correlations. R values close to +1 are also very strong. They would be very strong positive correlations. And then as we get close to 0, we're going to get weaker and weaker. So as we get closer to -1 or 1, that's going to represent a stronger correlation. As we get closer to 0, that's going to get weaker and weaker. So here we have some examples. Here we have what I would call a strong positive correlation. And we can see we have an R value of 0.83, which is relatively close to 1. Okay, so relatively close to 1 is on the stronger side. Here we have what I would say is a moderate negative correlation. And again, we can see that in our correlation coefficient. First of all, it's negative because this is a negative correlation. And then second of all, this 0.73 is still relatively close to 1, but it's a little bit closer to 0 than before. So this is moderate. Here we have a very strong negative relationship. Notice how close this is, super close to -1. Okay, so this is very strong negative. Here we have a weak positive relationship. Notice how close that 0.34 is relatively close to 0. So it's going to be weak. As we get closer to 0, it gets weaker and weaker. And in fact, this next one here is very close to 0. So close to 0, in fact, that this scatter plot, I would say, has almost no relationship at all. See how like almost random these dots look? There doesn't seem to be very strong or almost any trend at all. And the final one here, I would say, is moderate negative. Okay, folks, you have 2 examples down here that you're going to try. For each scatter plot, you're going to determine the direction, the strength, and then give the best guess you can for the R value. Okay, give the best guess that you can. Use this as a set of clues, okay, for determining what the R value should be for these 2. Okay, so try both this one and this one. Go ahead and pause this video for about 3 minutes and let students try these problems. Okay, we're back. Hopefully for this one, you said positive. And the strength, moderate. And are you ready to find out the real correlation coefficient? It was 0.551. So if you said 0.5, that was a very close guess. 0.6, I would say, is pretty reasonable. 0.4 is reasonable. If you said something very far away, just think about why you got that one wrong. Hopefully you didn't say it was negative, because then I'd be worried. But there you go. This one, the direction is definitely negative. The strength here is super strong. And the value of the correlation coefficient was negative 0.994. Again, I hope you had a reasonable guess for this. If you said negative 0.9, I think that's reasonable. If you said something very close to 0, that's pretty far off, okay? So this is super strong, so this should be very close to -1. Alrighty. We're on to the final flap. Bivariate categorical data. So again, bi means 2. So we have 2 categorical variables, and usually we want to see if they're related. And there are 3 tools that we learned about for dealing with bivariate categorical data. The first was we learned all about two-way frequency tables. And then we learned about 2 types of graphs that we can make. We saw grouped bar charts, and we saw segmented bar charts. So, first thing we learned about was all about two-way frequency tables. And we learned how to calculate marginal frequencies, joint frequencies, and conditional frequencies. Marginal frequencies is when I take a row or a column total and I divide it by the grand total. So, for example, if I took this 711, which is a row total, and divide it by 2,201, which is the grand total, that would be considered a marginal frequency. Then we learned about joint frequency. Joint frequency is when we take a cell total and we divide it by the grand total. So, for example, if I took this 203, which is a cell total, and divided it by this 2,201, which is the grand total, that would be considered a joint frequency. And then finally, we talked about conditional frequency. This is when you take a cell total and you divide it by, instead of dividing by the grand total, we isolate to a single group by dividing it by a column or a row total. So, for example, let's say I want to look at just the alive group and take 203 and divide it by 711. That would be a conditional frequency. My condition is that the passenger was alive. That's why we call it conditional. So we have a cell total divided by a row total. This last one is really important because this is the one that we use to create our graphs. And we're going to practice that here. So we have some data. Here is data of the survival status and the ticket class for passengers on the Titanic. So we have two variables, alive or dead, and the ticket class, two variables. And I want to know, is there a relationship between these two variables? So the first thing we need to do is identify our explanatory variable. And in this case, we're going to say that the ticket class is our explanatory variable. So that's what's going to end up being graphed on our x-axis. Okay? The explanatory variable always goes on our x-axis. And then for a segmented bar chart, your y-axis is always going to look like this. It's going to start at 0.1, and it's going to make its way all the way up to 1. It needs to go all the way up to 1 because for each of our categories on our x-axis, we're going to draw one big bar that extends all the way up to 1. So this is just how we set this graph up initially. Ignore the fact that my third class bar is a little short. It's supposed to go up to 1. Okay, and then we know what we're going to end up doing is we're going to break these into segments to represent the other variable. How do we decide how big those segments are? That's what we're going to do here by calculating some conditional relative frequencies. So let's start with the first class group. For the first class group, there were 203 out of 325 that were alive. So here we're calculating 203 divided by 325, which should give us 0.625. Okay, we're going to do the same thing for the dead category. There were 122 out of 325 that were dead. which is 0.375. Okay, let's do the second class now. There were 118 out of 285 that were alive, which should be 0.414. Let me double check that. Yep. And then for dead, it was 167 out of 285, which is 0.586. Okay, I'm going to pause here and show you what this will look like graphed. First of all, we need a couple of colors. We need alive and dead. Guest teacher, this might be a good time, if you haven't already, to pass out the color pencils on my desk to groups if they need them, if they want them. Okay, so for my first class, my alive section needs to be a height of 0.625. So I'm drawing my line at approximately there, and then I'm coloring in that section with my alive color. The rest of the bar is going to be made up by my dead color. Next, second class, 0.414 should be in my alive color. So I'm going to draw a line at approximately 0.414. I'm going to color in that section with my alive color, color in the rest of the bar with my dead color. Okay, I'm going to pause here. I want you to finish this off. So what you need to do is calculate the conditional frequencies for the other two classes and then color in your bars accordingly. Pause this video and give students about 3 minutes to do that. Okay, we're back. So you should have gotten 0.252 here, 0.748 here, 0.24 here, 0.76 here. So your graph ends up looking like this. And then the final thing I want to say about this is once you have a segmented bar chart, we want to know, is there an association between these variables? Is there an association between survival status and ticket class? And in this case, I would definitely say yes. There is an association between these variables. Specifically, first class were more likely to survive. Okay, so that's a final important idea here, is the idea of an association. Okay, are the variables related, basically? Okie dokie, you can use this flipbook on your test. You can use your calculators. You can use all of your data science notes, but you cannot work together. So we're going to be completely silent for the rest of the period. The guest teacher is going to pass out the test. Good luck and goodbye.